Okay, so again, it's very important that whenever you have an absolute value and it equals a number, when you drop the absolute values, it's automatically a positive and negative of that answer. Wow, this is taking ridiculously forever. Oh, this is section 5, I'm sorry. Second question number 2. All right, absolute value of x minus 6 is equal to 13. The procedures, whenever you have absolute value signs, you have to isolate the absolute value first, say it equal to some number. So the first step is isolate the absolute values. Drop the absolute values. Put plus or minus in front of the answer. So we drop the absolute value sign. So we have a plus or minus 13. Then solve both equations. We have x minus 6 equals positive 13. X minus 6 equals negative 13. One positive and one negative side. So you have to take this plus or minus into 2 parts. Add 6 to both sides. X 13 plus 6 is 19. Negative, positive, 13 is bigger, so it's negative. 13 minus 6 is 7. So those are our 2 solutions. Section 5, question 3. 5x plus 2 absolute value is equal to 8. Okay, we see absolute values are isolated, so we just drop them now. 5x plus 2 equals plus or minus 8. Do the positive on one side and negative on the other. So we have 5x plus 2 equals positive 8. 5x plus 2 equals negative 8. Now solve for x. Subtract 2. 5x equals 6. And divide by 5 both sides. So x is equal to 6 over 5. That's one answer. Subtract 2. So we have 5x is equal to negative. They're both negative, so we add them. Divide by 5. X equals negative 2. Those are my 2 answers. Pretty straightforward so far. All right. Section 3, Chapter 3, Section 5, Question 4. Absolute value of x minus 2 plus 8 equals 13. I'll take the penalty. All right. Notice the absolute value has a plus 8 on the side, so we have to get rid of that first. So we subtract 8 from both sides. 13 minus 8 is positive 5. Drop the absolute values. Then we have to put a plus or minus in front of the 5. So first step is isolate the absolute value. Drop the absolute value. Put a plus minus in front of the answer. Now solve both equations. One's the plus side, one's the minus. X minus 2 equals positive 5. X minus 2 equals negative 5. Add 2. X equals 7. X equals negative 3. It's also very, very advisable. Always check your answers. Make sure that they work, because there may be instances. So it's 7 minus 2 plus 8. Does that equal 13? 5 plus 8. So 5 plus 8 is 13. And likewise on this other side, negative 3 minus 2. Negative 3 minus 2 is negative 5. Absolute value of negative 5 is 5. 13 equals 13. Always check your answers. Make sure that they work. All right, here's question 5. Section 5, question 5. Absolute value of 2x plus 1 minus 6 equals negative 4. First step is what?
Isolate absolute value.
Yes. So we get rid of the 6. 2x plus 1. 6 minus 4 is 2. Drop the absolute value sign. Then we just put a plus or minus on the right-hand side. There's plus and there's minus. So it's 2x plus 1 equals positive 2. 2x plus 1 equals negative 2. Subtract 1. 2x equals 1, and divide by 2. Subtract 1. Negative 2 minus 1 is negative 3. So it's negative 3 over 2. And when you plug them in there, you'll see that they both work. But always, it's a good exercise to always check your answer. What's interesting is we're in this section says solving equations with inequalities, and we haven't seen an inequality yet. Ah, there we go, an inequality. Yoo-hoo! Yeah, that's true. So we have absolute value of 4x plus 4 is less than 8. Now it asks us to find the solution set and graph it. Remember, treat these the same way you do an equal sign. In chapter 1, we discussed the properties, the formulas, whenever you have greater than or less than. Does anybody remember those? What's the formula? If we have if it's less than, that means our x value has to go between, if it's less than a, that means it has to be greater than negative a. And if its absolute value is greater than a, then x is less than negative a, or x is greater than a. It goes both directions. So, I mean, once you have these written down, if you want me to, I can show you how those are derived, but it's just easier to just take it this way. So we have absolute values less than 8. We use this one. So that means here's the 8. It's going to be a negative 8 here and a positive 8 here. Whatever's inside there goes in the middle. Remember, you have to isolate it first. All right, so again, now we're solving for x. So this is the only one we're interested in. Whatever we do here, we do everywhere else. So first step, subtract 4 from everybody. Negative 8 minus 4, they're both negative. 8 plus 4 is 12. 8 minus 4 is 4. Again, now back to the middle. We're trying to get x by itself, so we divide by 4. Divide everybody by 4. Negative 12 over 4 is negative 3. The 4's cancel. And there's our answer. Right, because x is between there. They're both open circles because there are no lines, and it's between, x is between there. Yeah, so the only thing different between chapter 1 and this is the absolute values. Once we get to this point here, it's exactly the same what we did in chapter 1. And the 7th question, 1 minus x is greater than equal to negative 3. We can see automatically, just by looking at the equation, can we tell me what the answer is going to be? No, No, I said, no, with that, let's simplify it. Let's say we had this. Let's say we just had that. Absolute value of x is greater than -3. Are there any x I can put in there where the absolute value is going to be less than -3? No, I mean this is just observation. No calculations. Just anything you put in there. What happens when you take the absolute value of it? It'll be no. It won't be positive. It'll always be positive. If I put a -9 in there, the absolute value of -9 is 9. It's always going to be positive. Every positive is bigger than -3. So no matter what I put in there, from -infinity to +infinity, it'll always give me a true answer. So that's what's going to happen over here. And does it have to equal -3? No. This is greater than or equal to -3. So now, yes, now I was saying in conceptual is this. Now let's solve it the way we do using these formulas. Here's the greater than. So we drop the absolute value sign. We have 1 minus x is greater than equal to whatever a is. Then 1 minus x is less than equal to the opposite. Because you have x is less than negative a, so x is less than negative of that number. This is a. And we're using this formula. So x is less than negative of a. X is less than negative of a. Or x is greater than a. Here's a. So let's go and solve these. First step, subtract 1. -1 minus 3 is -4. Subtract 1. This becomes a positive. So we have negative x is less than equal to 3 minus 1 is 2. So far, so good. So negative and negative becomes a positive. So I subtract 1 from both sides, I get 2. I had to change the signs. And when I change the signs, I got to change all the inequalities also. So x is greater than equal to -2. And there's an or between there. So now, is this going to be infinity? Here we have -2. It's a block, and it's greater than, so it's everything over here going to infinity. That's this one. The other one says, here's 4. It's a solid dot, and it's less than, so it's everything over here going to -infinity. So we see everything's shaded, so it goes from -infinity to +infinity. Yeah, I mean, yeah, once you see the graph, picture's worth 1,000 words. Yeah, numerically, yes, these are numbers, but once you see it in the graph, if you overlap them, it includes everything. Everything less than 4, it goes to infinity, -infinity. Greater than -2 goes positive. No, it has to be an or. If it was an and, it would only be this. Where is x less than 4 and greater than 2? It's only this area here. That's why it's an or. It could be anything beyond this. So is negative 20, is that a possible answer? Yeah, because negative 20 is less than 4. And everything works, right? That's why you can't use and. All right, that does it. Was that? Yeah, that was question number 7. All right, so that does it for chapter 3. Let's look at chapter 4. Any questions about chapter 3?
No questions.
All right. Polynomials. Chapter 4. Polynomials and the algebra of polynomials. What is a polynomial? Okay, first off, x, 3, 3x, 5x squared, y to the 5th. These are all examples of monomials. Why is that? Each one only has one term. Monomials only have one term. It can have multiple letters and numbers in it, but there's no plus or minus. Two x plus 3, 5x to the 7th, y minus 3x, y to the 9th. Each one of these only have two terms, so these are called binomials. They have two terms. Two x squared plus 6x plus 1 is called a trinomial because it has three terms. Anything else beyond that? If you had four terms, we call it a quadrinomial, but that's just again too picky. So all of these are called polynomials. These are all under the subset of polynomials. Poly means many. So to define how ours is going to look, we say polynomial of degree. For example, this one is degree 7. The degree is the highest exponent. That's the degree, the highest exponent, the largest power. So how would you say this one as a polynomial? Polynomial of degree 2, or a second degree polynomial, right? The degree of the polynomial tells us the number of possible solutions. The degree of a polynomial tells us the number of possible solutions. The reason I say number of possible solutions, because an equation like this can have at most two solutions. Remember, solutions are x-intercepts. Solutions are x-intercepts. So we can have two solutions. We can have only one solution, or we can have no solutions. So that's why I say at the number of possible, at most, we'll have two solutions. The degree also tells us something else. Let's call the degree n. N minus one number of vertices. So whatever the degree is, we call that n. We'll have n minus one number of vertices. Remember, a vertex is the highest or lowest point of a curve. For example, if we have a binomial has degree 2, so it means we're going to have one vertex. So just by looking at an equation, we'll know the basic shape of it. We'll know we're going to have at most n number of intercepts and n minus one number of vertices. Algebra of polynomials. Whenever we use the term algebra of linear equations, algebra of polynomials, algebra, all that means is we can add them together, we could subtract them from each other, we could multiply them together, and we could divide them from each other. So whenever we talk about algebra of polynomials, that's what we're talking about. In other words, if I had one polynomial, p of x is 3x plus 5, and q of x is 4x squared minus 5x plus 7. These are the names of the polynomials. I can add the polynomials together. So we have 3x plus 5, that's p of x, plus 4x squared minus 5x plus 7, that's q of x. So this is p and this is q. I always put parentheses when I first write them down. I put parentheses just in case there's a coefficient in front of there or a sign change. Do I need the parentheses in front of the p? Is there anything in front of it? No. So I just drop the parentheses. And there's nothing in front of the second one. It's just a positive 1. So I could just put those down. Now I would just combine like terms. Start from the highest exponent. How many x squares do we have? We just have that one. So it's 4x squared. Next, we have x's. There's 3 minus 5. 5 is bigger, so it's negative. 5 minus 3 is 2. So those are the x's. Then the constants. Positive 5, positive 7 is 12. So there's my answer. That's the sum of two polynomials. Question? It's just complete combine like terms. But let's do q of x minus p of x. So what goes first is our q of x, which is 4x squared minus 5x plus 7 minus the p of x, 3x plus 5. Put in parentheses. I don't need the parentheses in the first since there's nothing out in front, so I just drop the first parenthesis. So it's 4x squared minus 5x plus 7. But the second one has that negative in front of it. So I have to multiply it to each term inside there. So it's negative 1 times 3 is negative 3x. Negative 1 times positive 5 is negative 5. Basically, all you do is change the signs. And combine like terms. Start with the highest exponent first. 4x squared. Negative 5x minus 3x, they're both negative. 5 plus 3 is 8x. 7 minus 5 is 2. We can multiply them. P of x times q of x. 3x plus 5 times 4x squared minus 5x plus 7. Now, this is why FOIL only works on binomials. This is distributivity. This is this, whatever's in front multiplies to everybody inside. The second one. So distribute. So everything in the first parenthesis has to multiply to everybody there. So 3 times 4 is 12. 1x times x squared gives us 3x's. Now the next one. Positive times negative is negative. 3 times 5 is 15. X times x is x squared. And the next one. Positive times positive is positive. 3 times 7 is 21. X. Okay, so that's the first one. Multiply it 3 times, it's finished. Now the 5. 5 times 4 is 20. I like to line them up. Since here are the x squares, I line them up under the x squares. 5 times 4 is 20, x squared. 5 times negative 5 is negative. 5 times 5 is 25, and x. And the last one is 5 times 7 is a positive 35. So all you have to do now is combine like terms. X cubed. 20 minus 15 is a positive 5. x squared. 25 is bigger than 21, so it's negative. 25 minus 21 is 4. And then the plus 35. And there's your answer. That's multiply. So no matter how big or how small, it's the same process. Distribute across. We're going to hold off and do the division a little later because there are long division and synthetic division, which I want to make sure we understand this stuff first before we jump into those. And dividing polynomials. It can be very, very, very cumbersome. So it's well, now we're going to look at division with a whole bunch of numbers, not just 2 numbers or 3 numbers. It's a whole equations. Ah, crap, I should have done this earlier. Or did I? Yes, I did. Okay. Where did it go? I pressed the button too many times. Yeah, I should have been checked this first. Listen. Yeah, see, but here's we're going to spend the whole time doing polynomial division. Okay, well, while we're waiting for this, let me also show you, no matter what size equation I give you, there are a few things we can know for sure. Right, so the n is 5. So we'll have at most 5 solutions or x-intercepts. We'll have n minus 1. 4, at most 4 vertices. Where do we get that information from? This first term. This first term is called the leading term. The leading term is x to the 5th. The coefficient of the leading term is called the leading coefficient. In our case, what is our leading coefficient?
1.
1.
But Mr. Meek,
yes.
So the degree of power doesn't always have to be the first one. It just has to be the first one after. It just has to be the highest, because you could always
It's highest, yeah. Yeah, actually, I'm glad you asked that. Sometimes the homework assignments are going to give it to you like this. What's the degree of that polynomial? People usually look at the first term. That's not the degree. The degree is the highest exponent. Right, so make sure that it's in decreasing order. I'm glad you asked that. Yeah, because make sure whenever you're in an equation that the highest exponent goes first and then goes down from there. And that degree tells us. Now, what else does the degree tell us? If it's even, then both ends point the same direction. Same direction. If it's even. If it's odd, then both ends point opposite directions. So if the degree is even, we know both ends are going to point the same direction, either up or down. If the degree is odd, then they point different directions. But the leading coefficient tells us which one's which. Remember, this is the A value, the leading term, A. If A is positive, it points up. If it's even and the coefficient's positive, it points up. If A is negative, it points down. This is the leading coefficient. Now, if it's odd, if A is positive, it's an increasing function. And if A is negative, it's a decreasing function. So now, why is this one called an increasing? Why is this one decreasing? Because we look at, right, exactly. We look left to right. As x goes to infinity, which direction is it going? As x goes to infinity, which direction is it going? That's how we determine it's increasing, decreasing.
You also can have fractions as degrees, am I correct?
Oh, well, I'm glad you asked that. If the degree is a fraction, if it's a fraction, then it's a radical. And it is possible because if n, the root, this is called a root. If n is positive, then it only goes to the right. If n, I'm sorry, if n is even, it only goes to the right. If n is odd, then it goes both directions. Because we did this square root of x, cube root of x. So yeah, it is possible to have a degrees fraction. All a fraction represents now is a radical.
Okay, that does make sense.
Yeah, it's counterintuitive, but yes, that's what does happen there. So from here, we look at the leading term. Leading coefficient tells us which direction it points, up or down. And if it's large, the larger it is, the more narrow it becomes. If A is greater than 1, it's more narrow. If A is between 0 and 1, it's more wide. So again, just by looking at this thing, we can tell whether it's going to be skinny, fat, pointing up, pointing down, how many vertices, and we also can tell our y-intercept. So we basically were formulating what the graph's going to look like way before we even touch it. So we know basically what it's going to look like. So this equation, since it's positive, has at most 5 intercepts. Our graph will look something like this. It crosses at 2. It's positive, so it's increasing function. 1, 2, 3, 4, 5. At most, our graph will look something like this. And to find these find these solutions and the number of them, that's what chapter 4 is all about. Okay, let me see if the question is popped up yet. Yes. Oops. Okay. Here's chapter 4, section 1, question 1. G of x is equal to negative 1 over 5 x to the 4th. Let me switch this over. Minus 5x plus 8. Determine, this one says, determine the leading term, the leading coefficient, and the degree, and classify it as a constant, linear, quadratic, or cubic. A quartic. So, leading term. What's our leading term?
1/5 x to the 4th.
Yes, 1/5 x to the 4th. It's the negative 1/5 x to the 4th.
Negative. Correct.
Yes. The leading coefficient.
-1. No.
It's whatever's in front of the x.
-1/5.
Negative 1 over 5, right. The leading term is whatever's the highest exponent. Leading coefficient is whatever's in the leading term, what's in front of the x. The degree, it's a fourth order degree. So now we classify it. Is it a constant, linear, quadratic, cubic, or quartic? Yeah, since it's 4, this means 3, this means 2, this means 1, this means has no x.
And it's an even number, so they're going to be going up.
Ooh, that's a new question. Yes. Okay. So we know this. The degree is even. So both ends point the same direction. Do they point up or down?
Oh, probably down.
Yeah, since the coefficient is negative, we know the graph will look something like this. I mean, we don't know what's going to happen inside here, but it's going to look something like that. Let me switch over. All right, it'll look something like this.
Okay.
Because it'll have 1, 2, 3, 4, at most 4 x-intercepts. But both directions, both ends will point down. We know that for sure. and quartic is a 4.
And you also said that the higher the coefficient, the tighter it's going to be. So that's if it was a higher coefficient, it would be like really shrunk in.
Right. This one's, you're right. This one's going to be more wide. Very good. Good observation. Yeah, because the leading coefficient is a fraction between 0 and 1. That means it's horizontally spread and vertically shrunk. Let me pull the next one up. All right, here's our next one. H of x is equal to 5.3x minus 5.41. It's going to ask us the same thing: leading term, leading coefficient, degree, and classify it. So what's our leading term?
$5.3x.
5.3x, yes. The leading term is the term that has the highest exponent. The leading coefficient. .3. What's the degree?
1.
Yep. 1. So if there's nothing up there, it's automatically a 1. So classify it. Yeah, linear has degree 1. And here's the third one. Same information: leading term, leading coefficient, degree, and classify it.
All right. LT 7.11 x to the third cubic, or x to the third.
Mm-hmm.
LC is 7.11. Degree is 3, and the class is trinomial.
Yeah, trinomial or cubic. It's going to be a no, it's not a trinomial.
No, right. Yeah,
because it doesn't have 3 terms. It's a cubic because it has degree 3.
Okay.
Okay, let's look at number 4. Okay, here we have to look at this. Okay, so here we have f of x equals square root of 11 x cubed plus 3x squared minus 2x plus 2. Tell me the end behavior of this graph. What are both ends going to do?
It's going to be 2 pointing the same direction.
So which letter is it?
I say C.
The answer is D.
D. Okay.
Because remember, what's the degree? Degree is 3. So since the degree is odd, that means both ends point different directions. Now, since the leading coefficient is positive, that means it's an increasing. That means as it goes to the right, it goes up. There. So yeah, so this way we have a basic idea what it's going to look like. All right, same concept here for the 5th question. P of x is equal to negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 5. Tell me the end behavior here. Yeah, the degree is 6. So it means they both either go up or down. And since the leading coefficient is negative, it points down. Because the degree is even, and it's a negative function. Oh, now we have a bunch of fractions. F of x equals 9 plus 1 over 9 x to the 4th minus 1 over 6 x to the 3rd. Tell me the end behavior.
They're going the same direction.
What's the degree?
4.
It's 4, right? So it means it's either going to go up or it's down. What's the coefficient, leading coefficient?
1/9.
1/9. It's positive, so they both go up. We know the graph will have this end behavior. Whatever happens in the middle, we don't know yet. All right, let me switch over so you can see this screen. F of x equals x to the 5th plus 1 over 14x minus 3. Choose the graph. So what letter? Okay, so the leading term is x to the 5th, right? Leading coefficient is 1. It's positive. The degree, let me switch it over. The degree is 5, so it's odd. So it's either going to look like this or like this. Since it's positive, it'll look like this. But this is important. It has to cross underneath the x-axis. So if we switch over, we have this one. But it can't be B because this is a decreasing, it's a negative. It can't be A or C, because that's an even degree. Has to be D.
They could have given us two choices that look like B.
Yes, they could easily done that, but we knew this one was not right because it's a negative coefficient. Find the zeros and state the multiplicity. All right, let me describe what's going on here. Let me 4.18. All right, this one's asking us to find the zeros and multiplicity. Come on, focus. Why is it not focusing? This is not good.
Maybe the lens has something on it.
Nope. Now move it closer. All right. Zeros are x-intercepts. How many solutions are we going to have here?
3.
Two vertices. So
This means x plus 1 to the third means this happens 3 times. And this one is just once. But all of these are the same answer. To find the zeros, whatever's inside the parentheses, take and set them equal to 0. So we only have 2 zeros, 2 x-intercepts. One's at x equals -1, one's at x equals 1. The multiplicities. The multiplicities of this first one is the exponent. So the multiplicity of the x equals -1 is 3, because this one happens 3 times. And this one only once. So now the question is, what is the importance of a multiplicity? The multiplicity tells us if the graph will cross or touch the x-axis at that point. The multiplicities tells us if the graph will cross or simply touch the x-axis at that point. We've seen this before. If it touches, remember this, what kind of equation is this? If it has a parabola as a graph? It's a quadratic, yeah. And it's even number, even degree. So both of these answers are the same. So therefore, its multiplicity is 2. It just touches. So if it's an even multiplicity, what do you think happens? Yeah. Even touches the x-axis at the point, and odd, it crosses. Yeah, at both of these points, at -1 and 1, it's going to cross. What's the degree of this equation? Three plus 1 equals 4. Because they're all multiplied together. So if they're all multiplied together, the degree is if you add up all the exponents. Okay. So if I gave you a function like this, what's the degree?
But if there's a plus or a minus sign in some more x's, then it's
It's still this. It's the highest exponent. Whatever the highest sum is. The degree is 5 plus 7 plus 2 equals 14. That's the degree. But you're right. If it was x to the 5th plus y 7th z 2nd, the degree of this one is 9 because it's only these two added together. Make sense? So the degrees and multiplicities working together tells us whether the graph is going to cross at that point or not. Find the zeros and state the multiplicities of each. Okay. Here's the next one. F of x equals -2x plus 3, x plus 3, x plus 3, x minus 4. It says find the zeros and state the multiplicities. So what are the zeros?
x equals -3. X equals 4.
And the multiplicities? Because all of these are the same. So it's x plus 3 to the 3rd, x minus 4. So what's this graph going to look like?
So it'll cross the x-axis 3 times, and then it'll just touch the x-axis.
No. No. We know it's going to cross at -3. You know it's going to cross there. We also know since the multiplicity is 1, it's going to cross at 4. The degree of the equation, it's a 4th order degree, which means both will either point up or point down. Which one is it going to do? it's going to point down because it's -2. So, and it could look anything like this. Or it could just be, we don't know what's going to happen in the middle just yet. We don't know how many vertices we're going to have. But this is all we know for sure, is that the endpoints are going to be pointing down, crossing through -3 and 4. All right. F of x equals x squared minus 25 to the 5th. The smaller 0 is, and the multiplicity is, order of operations. Can we do anything inside the parenthesis? Remember, is 25 a perfect square? It's a difference of 2 squares. So we have x minus 5 and x plus 5. And since these two are multiplied to each other, I distribute that exponent to both of them. So the zeros and multiplicities are where? Mm-hmm. And so the degree is 10. And we could see that from here. This exponent times the highest will give us a degree of 10. So whenever you have a power inside and a power outside, you multiply them. So that's how it works out. So always look to see if you can do anything inside the parenthesis first. Now with this one, find the zeros and multiplicities. Since, okay, we learned how to solve linear equations and quadratics, but now since we have 4 terms, we have another method to introduce. It's called grouping. Let's group the first 2 terms together and the last 2 terms together. This negative goes with that x. What can we factor out of the first one? What do they both have in common? They both have an x squared, don't they?
Okay, I wasn't sure if we were able to do that.
Yeah, anything is the same, you can pull it out. So if I take out 2 from here, I just have 1 left. And that. That's the first parenthesis. How about the second parenthesis? What do they both have in common? They both have a negative. Yeah, so I take out the negative. So I change their signs. What we're trying to do is whatever's inside the parentheses, we want to try and make them look the same. Because now we have 2 terms here. We have this term and that term. What do they both have in common? The x plus 19. They both have an x plus 19, so I take it out. What do I have left inside there? It's whatever's in front. X squared minus 1. Now this one can go further. Isn't 1 the same thing as 1 squared? So it's a difference of 2 squares. X minus 1, x plus 1. Yeah, so the 0 of this one is negative 19 with multiplicity 1. 0 of 1 with a multiplicity of 1. 0 of negative 1 with multiplicity of 1. Okay, so if we drew the graph of this thing, we know we have zeros at negative 19, at negative 1, and at positive 1. Where else do we have an intercept? At negative 19, right. What's the graph going to look like? What's the end behavior?
So it's going to be increased.
Right, because the coefficient is positive, it's an odd, so it'll look like this. So this end has to be going down, this end has to be going up. It looks something like this. So we go rough sketch it really quick and then find certain points. All right, so let's go ahead and leave it there, and we'll pick up on Wednesday. We're going to do from here. So yeah, just practice these. Go over and do that section homework again. Review for your test for chapter 3 as well, and take that when you're good and ready. Okie doke. Then I will see everybody on Wednesday.
Okay, thank you.
All right, have a good day, everybody.
You too,
Thank
thanks.
you, you too, thanks.